Alright folks, let's do this little example here. I have this figure. It's kind of a, I don't know, it kind of looks like a ticket in some sense, but there's a triangular end here. I'd like to find both the area and the perimeter of this figure. So, I think a good idea is for you guys to try this first before you continue on with the video. I will point out a couple of things. Well, this is kind of like, again, what I said. We have kind of like a rectangle here, but there's this semicircle. I tried to draw a semicircle, so imagine that this is a semicircle missing from this. And then we have this triangle at the end here. And I do want to say that this kind of line to the center divides this kind of height here, 10, directly in half, so each side is indeed the same length. So pause the video now, see if you can work this out. Okay, now that we're back, let's kind of piece together what's going on here. We'll start with the area. So, the area of our figure in total, well, it's going to be, we have this like rectangular object here, but it's missing this semicircular bit. So, we're going to have, if we figure out the area of the rectangle, and we take off the area of the semicircle, and we'll talk about how to do these in a second. And we also have this area of the triangle we can add on as well. So we add on the area of our triangle. Oh, that's a, not a triangle. There we go. So if I figure out these things, the area of the rectangle itself, and then take away that little semicircular bit there, so half of this circle, and then add on the area of this this triangle at the end, then I'll find the area of the entire figure. Well, the area of this rectangle, this is pretty easy. Let's work that out. The area of this rectangle, it is 12 units one way, 10 units the other way, so it's 120 units squared in total, 12 by 10. Great. So, now we need to be able to figure out the area of the semicircle in order to take away this bit here. Okay, let's go ahead and do that. So, remember, to figure out the area of a circle, we need its radius. So, we know that there is 3 units here, 3 units here. This is a rectangle. So in total there's 10 units on the vertical sides. So we're missing 4 units here. So I'll do this in green, I guess. So this here is 4 units. That's the diameter. It goes from one side of the circle to the other. And since this is half a circle, it goes through the center. If you're cutting a circle in half, you have to cut it through the center. So what's the radius going to be? The radius here in solid green that I'm going to draw, the radius is half of that. It's 2 units. So I know that the area of my semicircle is going to be the area of the circle with the same radius, but it's half of it, since it's half a circle. It's the circle, but half of it. So we know that that's going to be pi times, well, the radius is 2, so 2 squared over 2. So that's 4 pi divided by 2, which is 2 pi. And we'll just leave it like that for now. So that's what we're going to subtract. And then we have the area of our triangle. Again, this isn't too bad. We can look at the triangle so that this side here is the base, and then this here would be the height. So the area of this triangle is going to be base times height divided by 2. Base times height divided by 2. So that's 10 times 12 divided by 2, which is, of course, 60 units squared. And I should put 2 pi units squared here, too. So let's put all this in. So this equals 120 minus that little bit, 2 pi, plus 60, which is 180 minus 2 pi. This is a nice exact answer. If we wanted to approximate it, well, we could just make pi equal 3.14, and then 2 times 3.14, you can check, is 6.28 units squared. So it's approximately 180 minus 6.28 units squared, which is, if I do that subtraction, 173.72 units squared. So there's the area of this figure. Let's now find the perimeter of this object. Let's see what we know and what we need to find. So we know this side, we know this side, we know this side. We need to find the length of this half circle here. We know this side, and we need to solve for the sides of our triangle here. So there are the two things we need to solve for. So these guys meet at a right angle, which is nice. So that tells me that indeed I can just use the Pythagorean theorem to solve for my unknown side. I'm going to call the unknown side, this unknown side I'm going to call C, I guess. So I have this right angle triangle here. This length here is half of 10. So this length is 5, and this length is 5 as well. So I know that a squared plus b squared equals c squared. So 5 squared plus 12 squared equals c squared. Remember, this is our hypotenuse. That's the one opposite the right angle. So it's the other two squared, and then sum them together equals the hypotenuse squared. And we'll talk about that very soon, why that's the case. And if we solve this, we get 25 plus 144 is 169, is c squared, and the square root of 169 is indeed 13. So we know the length of this side is 13. We know the length of this side is 13. So all we need now is indeed the length of our semicircle here. And again, it's half a circle, so it's going to be half the circumference. So we need to find, again, I'll do this in green, the circumference over 2. So remember, that's pi times the diameter, or pi times 2 times the radius. I'll write it as 2 pi r over 2. Here's the circumference, 2 pi r over 2, since it's half a circle. And, well, our 2's cancel out. And we're just left with pi times r, which is indeed pi times 2, which is 2 pi. Great. Okay. So, we know that the length of our semicircle here is indeed 2 pi. Now the perimeter, we're just going to add all of these up. So let's go ahead. Let me scroll down just to get a little more room for us. There we go. Let's start. I'm going to start at the 12, and I'm going to go clockwise. Okay, so the perimeter of our shape is 12 plus 13 plus 13 plus 12. That gives us both sides of our rectangle here, and it gives us both sides of our triangle. Okay, and then we just have this bit left, so that's 3 plus 2 pi plus 3. And let me count, make sure I have everything. 1, 2, 3, 4, 5, 6, 7 things. 1, 2, 3, 4, 5, 6, 7 things. Looks good. I add this up. I'm going to do this fairly quickly. So 12, this is 26. So 12 plus 26 is 38. Plus another 12 is 50. This is 53, 56 plus 2 pi. So it's 56 plus 2 pi. This is a fine way to leave your answer if you're asked for an exact answer. And our units are just regular old units. Perimeter is a one-dimensional measurement, so the units just are units, not units squared or units cubed or anything like that. And if we want to approximate this, of course, it's going to be 56 plus, well, 2 times pi is 6.28, which is 62.28 units is our perimeter.